Hi friends, in this video we're going to look through some examples of using our exponent rules. If you need to go through those exponent rules, there's a previous video that rolls through what the rules are and how we would apply them. So you want to watch that before you get to this one. All right, let's look at some examples. So the first one I have is just a very basic exponent rule problem. We have 4 raised to the second power and that whole thing cubed. And if you remember, that means that we have 4 to the 2 times 3 power, which would be 4 to the 6th power. Now, remember that that exponent on the outside gets applied to everything inside the parentheses. So if I were to write out this next problem of parentheses 2x close parentheses cubed, I could write it out the long way as 2x times 2x times 2x. Now, I'm not going to do that on any of these problems because it just gets too long and too complicated. We want to apply our rules, but it's helpful to see why the rules apply. Notice that the 2 gets multiplied by itself 3 times, and the x also gets multiplied by itself 3 times. So we end up with 2 cubed times x cubed, which would be 8x cubed as our final answer. So it's important to remember that that exponent gets applied to everything within the parentheses. On this next one, that's especially important because I have a negative here. So this would be negative 3 squared times y squared. So negative 3 squared is of course going to give me a positive 9. And y squared we just write down. But remember that that negative also gets squared to make a positive. That's a really easy mistake to make. So we want to be very careful anytime we see a negative with an exponent. We could have more than 2 things within those parentheses. In this example, I have parentheses 5xy, close parentheses, whole thing squared. So that would be 5 squared times x squared times y squared. Well, 5 squared we know is just 25. And then x squared and y squared just get written down. There's nothing else we can do with that. So our final answer would be 25x squared y squared. So in my next example, I have negative 2x squared y times 4x. No parentheses here, but we do still need to simplify this. So remember, it's all being multiplied together. I want to make a few little adjustments here. I'm going to write that sneaky 1 on the y and the x so that we remember that they do have an exponent. We just don't always write it, but it's okay to add that into your problem. So I'm going to rewrite it as negative 2x squared y to the first times 4x to the first. I'm going to do one more thing. Remember that we can change the order that we multiply things. 2 times 3 is the same as 3 times 2. So I'm going to rewrite this as negative 2 times 4 times x squared times x to the first times y. Now, you might wonder, why bother doing that? And the reason is, I grouped up the things that I can combine into a single term, or into one multiplication. So negative 2 times 4, well, I can rewrite that as negative 8. X squared times x to the first, well, that would be x to the 2 plus 1, or x to the 3rd power. And then, well, y doesn't have anything it's multiplied by, so we just write it down anyway. So my answer would be negative 8x cubed times y. Remember that your numbers can combine together and your same variables can combine together, but then that's where we have to stop. All right, let's look at another problem. Up here on the right-hand side, I have parentheses, 3x squared y, all of that to the third power. So we want to be pretty careful as we do this one. We know that each of those things inside the parentheses are going to be raised to the third power. So I would have 3 to the third power, x squared raised to the third power. And I'm going to go ahead and put that x squared in parentheses so that I remember that that is a power raised to a power. And then that's times y to the third power. I need to go back and deal with this x squared to the third power. So we want to use our exponent rules. We know that x squared to the third power is just going to be x to the sixth power. And then that 3 to the third power, I could use my calculator, or I could multiply it out. But 3 times 3 is 9, times another 3 is 27. And I would definitely want to multiply that out. If you can evaluate a number to a power, you definitely want to. So my final answer would be 27 from the 3 to the third power, x to the sixth, and that came from x squared to the third power, times y to the third power. All right, my next problem involves a division. We might have done a lot of multiplication problems, but now we're going to do at least one division problem. So we have parentheses 2x, close parentheses, squared, divided by 3x. Now it's very tempting when you see that x in the numerator and the x in the denominator to cancel those. However, think order of operations. The first thing we have to do is evaluate what's happening inside those parentheses and then deal with the exponent. So we want to deal with that 2x quantity squared before we deal with multiplication and division. Order of operations never goes away. All right, so in the numerator, I have 2 squared, which I'm just going to write as 4, and then x squared. And that's going to be divided by 3x. Now I have x squared over x to the first. Don't forget that sneaky 1. And then a 4/3. So I'm going to write the 4/3 on the outside. And then this would be x to the 2 minus 1 power, or just 4/3 x to the first power. Now, I also could have written this as 4x over 3. That would be just fine. It means exactly the same thing. And if that's more comfortable, then that's the way you should write it. All right, next example, we've got 2 sets of parentheses to deal with. So we want to evaluate those separately and then combine them together. So I have 5x in parentheses cubed times 3x in parentheses squared. So 5x in parentheses cubed would be 5 to the third power x cubed. And then 3x in parentheses squared would give us 9, or 3 squared, x squared. we have a few things that we can simplify. First, I'm going to rewrite 5 to the 3rd power as what it's equal to. So 5 times 5 gives me 25, times another 5 is 125. So I would have 125x cubed times 9x squared. Then we can combine our number part together and our variable part together. So 125 times 9, now normally I would probably grab my calculator to work that out, but let's see, that would be, I believe that would be 1125 when we multiply 125 and 9. Yeah. And then we have x cubed times x squared, which would be x to the 5th power. So my final answer would be 1,125 x to the 5th power. All right, 2 more, and these look really similar because I want to make a point about those negatives. So the first one is negative of 4x squared. Notice there's no parentheses there, times, in parentheses, negative 3x squared. All right, really throwing the negatives at you because they're super important. So we don't have any parentheses here. That tells me that the squared piece is only attached to the x. This negative 4, that's just on the front. It's like a decorative negative 4. Nothing is happening to it other than it's a coefficient. However, when I have this negative 3x in parentheses, the whole thing is being squared. So let's write out another step here. I have negative 4x squared times negative 3 in parentheses squared times x squared. And let's evaluate that. This would be negative 4x squared times positive 9 x squared, because negative 3 squared gives us positive 9. And then finally, we can group up our number piece. Negative 4 times 9 is negative 36. And our variable piece. So x squared times x squared would give me x to the 4th power. Now, in my second example, it looks a little bit different, and I want to show you the different part. That squared is not on the outside of the parentheses, it's just on the x. And it makes a big difference. So because that squared is just acting on the x and not the negative 3, x is the only piece there that gets squared. So I could rewrite this as negative 4x squared times negative 3x squared. Negative 4 times negative 3 would give me a positive 12. And x squared times x squared is x to the 4th. So 2 major differences. That squared is only acting on the x, not the negative 3. So it's going to change not only our number here, but whether it's positive or negative. So we want to be extra careful around negatives and exponents. In the next video, we're going to talk about square roots, which are a special type of exponent, although we don't always think of it as an exponent. And we'll be evaluating those and talking about how they relate to exponents.